Mastering elbow notation. In this short video, we will learn how to use and master elbow notation in counting problems. Let us begin. In how many ways can one buy two ice creams of the same flavor? The answer is only one, which is correct. In how many ways can one buy two ice creams of two flavors, two different flavors? Let us consider the following scenarios. 0 ice cream of flavor A and 2 ice creams of flavor B, 1 ice cream of flavor A and 1 ice cream of flavor B, 2 ice creams of flavor A and 0 ice creams of flavor B. So we have three possible ways of buying two ice creams with two different flavors. In other words, we need to find the number of ways two whole numbers can be added to get 2. This can be expressed algebraically as x1 plus x2 is equal to 2, where x1 and x2 are whole numbers. Looking at the diagram, we can explain this as 0 plus 2 is equal to 2, 1 plus 1 is equal to 2, and 2 plus 0 is equal to 2. But symbolically, we can write the first case as first separator and two stars, second case as two stars and separator in between, and the third case as two stars followed by separator. It also means in how many ways we can arrange two stars and one separator. So the answer for all these questions is same, which is 3, but stars and separator way of looking at these things, it is easy to evaluate as it is permutations with repetition. Let us see if it works for 3 ice creams with 3 flavors. These are the 10 different ways by which we can buy 3 ice creams with 3 different flavors. It's like how many ways 3 whole numbers can be added to get 3. Algebraically, it is x1 plus x2 plus x3 is equal to 3, where x1, x2, x3 are whole numbers. Answer seems to be like arranging 3 stars and 2 separators, which is 5 factorial upon 3 factorial into 3 factorial, which is equal to 10. So again, we are looking at this problem from permutations with repetition point of view, and it becomes easy to solve. So in general, we can say if there are n whole numbers which can be added to get r, we can write it algebraically as x1 plus x2 plus x3 dot 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 plus xn, which is equal to r. The answer is denoted by the new notation n elbow r, and it is said n elbow r, which is r stars and n minus 1 separators. Hence, n elbow r is equal to r plus n minus 1 choose r, or r plus n minus 1 choose n minus 1. Now we will solve several different problems to understand these different situations and arrive at correct answers. Let us consider first problem. It is similar to what we have discussed. Suppose there are 10 people in the party and you want to buy 10 ice creams of 4 flavors. In how many ways you can do it? This is similar to asking a question in how many ways 4 whole numbers can be added so that we get 10. So algebraically, x1 plus x2 plus x3 plus x4 is equal to 10, and all x1, x2, x3, x4 should be greater than or equal to 0. The answer is 4 elbow 10. Let us make the question little difficult. In how many ways one can buy 10 ice creams out of 4 flavors, say A, B, C, D, if minimum one ice cream of flavor A must be bought. Now there is a condition on A. We cannot buy 0 ice creams of flavor A. Therefore, algebraically we will write this question as x1 plus x2 plus x3 plus x4 is equal to 10, but x1 is greater than or equal to 1, whereas x2, x3, x4 can be greater than or equal to 0. Here what we will do is we will replace the variable x1 by y1 plus 1. What will happen? If x1 starts from 1, then y1 starts from 0. We can see that. If x1 is equal to 1, then y1 is equal to 0. If x1 is equal to 2, y1 is equal to 1, and so on. Therefore, by changing the variable, we will convert the given equation into y1 plus 1 plus y2 plus y3 plus y4 is equal to 10. And therefore, eventually we will get the equation y1 plus x2 plus x3 plus x4 is equal to 9, where all y1, x2, y3 and x3 and x4 are greater than or equal to 0. Now this is simple to solve because the answer is going to be 4 elbow 9. What is the difficulty that we added in this problem? That there was a lower limit for one value x1. Using change of variable, we have solved this problem successfully. The answer is going to be 4 elbow 9, which is going to be smaller than 4 elbow 10, because we are not considering the cases where x1 is equal to 0. Let us look at the third problem. What we are changing it is that minimum 1 ice cream of flavor A and minimum 2 ice creams of flavor B must be bought. Now we are putting lower limit to 2 flavors, 2 variables. So what is the algebraic form of this problem? x1 plus x2 plus x3 plus x4 is equal to 10, given 1 is less than equal to x1, 2 is less than equal to x2 and x3, x4 are greater than equal to 0. So the same trick will work here for x1 and x2, which we have used in earlier problem. Let x1 is equal to y1 plus 1 and x2 is equal to y2 plus 2. Change of variable. So if 1 is less than equal to x1, then 0 is less than equal to y1. And if 2 is less than equal to x2, then 0 is less than equal to y2. Hence our new equation becomes y1 plus 1, which is x1, plus y2 plus 2, which is x2, plus x3 plus x4 is equal to 10. So if we just shift those 1 plus 2, that is 3, to the right hand side, we get the new equation as y1 plus y2 plus x3 plus x4 is equal to 7. And now all the variables y1, y2, x3 and x4 are greater than equal to 0. They can start from 0. And then it is our standard elbow notation problem, whose answer is 4 elbow 7, which is 10 choose 7 or 10 choose 3. So now we note that if we have lower limit for any of these 4 variables x1, x2, x3, x4, we can always change the variable and handle the lower limit of this problem. So there can be many problems which can be designed with different lower limits or same lower limits, which we can solve very easily. Now let us increase the difficulty a little bit by putting the upper limit. So the next problem is same, how many ways you can buy 10 ice creams of 4 flavors, and maximum 2 ice creams of flavor A can be bought. So now algebraic form of this problem is x1 plus x2 plus x3 plus x4 is equal to 10, given 0 is less than equal to x1 is less than equal to 2, and x3, x4 and x2 can take values greater than equal to 0. So now this is little difficult situation, because in earlier cases, if we choose 3 ice creams of flavor A and say 3 ice creams of flavor B, 3 ice creams of flavor C and 1 ice cream of flavor D, that was acceptable counting. But now because x1 is greater than 2, that counting should not be considered in this particular problem. So it is to handle the upper limit. How do we handle the upper limit? In this case, x1 can be maximum 2. Hence, x1 between 3 to 10 is not acceptable. In 4 elbow 10 ways, we have all x1, x2, x3, x4 starting from 0 with no upper limit. As we have upper limit for x1 now, we count all those cases when 3 is less than equal to x1 and subtract them from 4 elbow 10. That is the strategy we will use, because we can very easily handle the lower limit, and therefore all unwanted cases will be x1 plus x2 plus x3 plus x4 is equal to 10 and x1 is greater than or equal to 3. x2, x3, x4 are greater than equal to 0. So this answer we can find out. Put x1 is equal to y1 plus 3. So if x1 is 3, y1 will be 0 and so on. Therefore, our new problem becomes y1 plus x2 plus x3 plus x4 is equal to 7. And now 0 is less than equal to y1, x2, x3 and x4. This is our standard problem. So we have calculated the unwanted cases, which are 4 elbow 7, which need to be subtracted from original answer. If there was no upper limit for A, the answer would have been 4 elbow 10. So final answer will be 4 elbow 10 minus 4 elbow 7. Now let us make the problem more difficult by putting upper limit to two variables. So the new problem is, you can buy maximum 2 ice creams of flavor A and maximum 3 ice creams of flavor B. So algebraically we can represent this problem as x1 plus x2 plus x3 plus x4 is equal to 10 with 0 less than equal to x1 less than equal to 2, 0 less than equal to x2 less than equal to 3 and x3 x4 greater than equal to 0. So in this case, maximum value of x1 is 2. So we can think this problem as finding out the complement of x1. That means if x1 is between 3 to 10, the case is not acceptable. The counting will not be acceptable. And if x2 is between 4 to 10, the counting will not be acceptable. So in 4 elbow 10, we have counted when all of them were starting from 0 and with no upper limit. As we have upper limit for x1 and x2 now, we will count those cases separately and subtract from 4 elbow 10. So let us calculate unwanted cases for x1. It is similar to earlier problem. Therefore, we will get y1 plus x2 plus x3 plus x4 is equal to 7, and all 4 variables now y1, x2, x3 and x4 are greater than equal to 0. Therefore answer will be 4 elbow 7. Those are unwanted cases because of x1. Similarly, unwanted cases because of x2. This is only x1 and only x2. If x1 is greater than the required value, then we have found out unwanted cases for x1. At that time we are not considering what is x2. Now unwanted cases for x2, when we are calculating, which is 4 elbow 6, we are not considering what is the value of x1. Okay, so individually we have calculated unwanted cases for x1 and x2, which are 4 elbow 7 for x1 and 4 elbow 6 for x2. So now consider a case when x1 is also greater than 2 and x2 is also greater than 3. That means x1 is equal to 4. Say for example, this case x1 is equal to 4, x2 is equal to 5, x3 is equal to 0 and x4 is equal to 1. This particular case is counted in our 4 elbow 10 total counting. And you will find that because x1 is greater than 2, we have to subtract this case because of x1. But because of x2 also we have to subtract it. x2 is also greater than 3, 5. Therefore, we have to subtract it because of x2 also. But then we have included this case once in 4 elbow 10. We have excluded this case because of x1 in 4 elbow 7. and we are excluding it again because of x2 4 elbow 6. That means we have excluded twice and included only once, which is going to lead to the wrong counting. Unnecessarily you are excluding two times and you have included only once. So if you don't want this case to be counted, it should be included same number of times and excluded also same number of times. Therefore what we have to do is we have to find if simultaneously both x1 and x2 are greater than their upper limits, then what? So we will change the variable x1 to y1 plus 3, we will change variable x2 to y2 plus 4 simultaneously and find out, solving new equation, y1 plus y2 plus x3 plus x4 is equal to 3 now. So these are the cases when both x1 and x2 are greater than their upper limits. So these cases are included in first counting 4 elbow 10, excluded because of x1 in 4 elbow 7, excluded because of x2 in 4 elbow 6, and therefore we need to add them in the counting eventually once. Therefore 4 elbow 3 should be added. This particular principle is called inclusion-exclusion principle in counting, and is very powerful tool for arriving at correct count. Now in next problem, let us put upper condition on two variables, but the condition, let us keep the condition same. So the new problem is now in how many ways? 5 whole numbers x1 to x5 can be added such that the total becomes 10, and the condition on x1 and x2 that they should be between 0 to 10. Okay, this is similar to earlier problem, but now the upper limits for both, in earlier problem they were different, now it is same. So this is going to be little easy calculations. The principle of solving is going to be the same. So x1 plus x2 plus x3 plus x4 plus x5 is equal to 50. x1 is between 0 to 10 and x2 is also between 0 to 10. x3, x4, x5 are greater than or equal to 0. So total count without any restriction will be 5 elbow 50. Right? Now both x1 and x2 have same upper limit 10. So unwanted cases because of x1, we have to consider value of x1 from 11 onwards. So we subtract 11 from RHS and get the answer. Unwanted cases for x1 will be 5 elbow 39, and similarly unwanted cases for x2 also will be 5 elbow 39 individually. However, because we will subtract because of x1 and because of x2 two times, we will have to consider the case when x1 and x2 both are simultaneously greater than 10. So in that case, by change of variable, the way we did it in earlier problem, we should find out the cases which we should include, because we have excluded two times, will be 5 elbow 28. That will be x1 plus 11 plus x2 plus 11 plus x3 plus x4 is equal to 50. So if you subtract those 22 from 50, you will get that 28, and hence include all 5 elbow 50, exclude because of x1 5 elbow 39, exclude because of x1 5 elbow 39, and include because of x1 and x2 both will be 5 elbow 28. So now once we understand the procedure, we need not have to really get into the details. How is it going to happen? In initial problems, we want to learn how it happens. Therefore, we broke it down in small pieces and understood how it is happening. But now inclusion-exclusion principle is going to take over, and it is going to be very strong in finding out correct answers. So correct answer for this is 5 elbow 50 minus 2 times 5 elbow 39 plus 5 elbow 28. Now in this problem, what we are trying to do is increase the difficulty level by putting lower limit and upper limit to two variables x1 and x2. So the problem is x1 plus x2 plus x3 plus x4 plus x5 is equal to 50 with 2 less than equal to x1 less than equal to 10, 3 less than equal to x2 less than equal to 8 and x3, x4, x5 are greater than equal to 0. Okay. So now first we need to deal with lower limits. So we substitute x1 and x2 as y1, x1 is equal to y1 plus 2, x2 is equal to y2 plus 3, and therefore in LHS we have 2 plus 3, 5, we subtract it from 50 and hence the equation becomes y1 plus y2 plus x3 plus x4 plus x5 is equal to 45. Now it can be visualized as, suppose we want to buy 50 ice creams of 5 flavors and somebody has said that I want 2 ice creams of this flavor and somebody else has said I want 3 ice creams of this flavor. So instead of making the problem difficult by putting lower conditions, lower limits, it is as good as the moment you go to the shop, you buy those 2 ice creams of first flavor, put it in your bag, buy 3 ice creams of the second flavor, put it in your bag, and now you solve the new problem. The new problem will be y1 plus y2 plus x3 plus x4 plus x5 is equal to 45 with lower limit at 0 for all of them and upper limit for y1. Now earlier upper limit for x1 was 10, but because we have already put 2 ice creams in the bag, the upper limit for y1 would change from 10 to 8. For x2 it will change from 8 to 5, and hence the new conditions on y1 and y2 will be 0 less than equal to y1 less than equal to 8, 0 less than equal to y2 less than equal to 5, and x3, x4, x5 will be greater than equal to 0. Correct? So total count without any restrictions on y1, y2, that means y1 and y2 start from 0 will be 5 elbow 45. Then because x1 has got upper limit 8, we have to subtract 9 from 45, and unwanted cases because of y1 will be 5 elbow 36, and because the upper limit of y2 is 5, we have to subtract 6 from 45. So unwanted cases for y2 will be 39. So unwanted cases for y2 will be y1 will be 5 elbow 36, y2 will be 5 elbow 39, which we have to subtract. But then we will find that simultaneously if y1 and y2 are greater than 8 and 5, then we will have to subtract, we will have to add the case of simultaneous existence of y1 and y2 greater than the required as inclusion, and therefore that will be 5 elbow 30. 5 elbow 30 need to be added. Hence, in this particular problem, the final answer will be 5 elbow 45 minus 5 elbow 36 because of x1 minus 5 elbow 39 because of x2 and plus 5 elbow 30 because of x1 and x2 simultaneously greater than the upper limit. Let us see next problem. In how many ways 5 whole numbers x1 to x5 can be added such that the total is 50 and 1 is less than equal to x1, x2, x3 less than equal to 7, 0 is less than equal to x4 less than equal to 5, and 0 is less than equal to x5. So we have conditions on first 3 variables, they are same, lower and upper limit is same, and fourth variable we have upper limit. So in this case lower limits are taken care, then revised problem statement will be in how many ways 5 whole numbers y1, y2, y3, x4 and x5 can be added such that the total is 47. every time you will replace y1 plus 1, y2 plus 1, y3 plus 1 in place of x1, x2, x3 respectively. So you will get that 3 in LHS which will transpose to RHS, and hence you will get RHS 47. Therefore include all 5 elbow 47. Now because of 1, if we are excluding, we have to change the upper limit of y1, y2, y3. Given problem x1, x2, x3 have upper limit 7, but because we have got the lower limit shifted to 0, upper limit also will shift to 6 instead of 7. And therefore if we want to exclude because of y1, it can be done in 5 elbow 40 ways. You have to subtract 7. Similarly y2 5 elbow 40, similarly y3 5 elbow 40, but for excluding x4 we have to subtract 6 from 47, and hence it can be done in 5 elbow 41 ways. So exclusion, every individual exclusion, because the number is going to be higher than the required, we excluded 4 of them. Then we have to consider including 2 at a time. So if we include y1 and y2 at a time, then the count will be 5 elbow 33. That means 7 for y1, 7 for y2 to be subtracted from 47, that is 33. So 5 elbow 33. Similarly for y1, y3 5 elbow 33, y2, y3 5 elbow 33, and then you will have to consider including y1 and x4. So when it comes to y1 and x4, 7 and 6, 13 you have to subtract from 47, so it becomes 5 elbow 34. Then y2 and x4 will become 5 elbow 34, and y3 and x4 will become 5 elbow 34. So these are the 6 cases which you need to include. Then you have to exclude because of 3. So if they are y1, y2, y3, you have to exclude 5 elbow 26. If it is y1, y2, x4, 5 elbow 27. y2, y3, x4, 5 elbow 27, and y3, y1, x4 will be again 5 elbow 27. So excluded. And now if all of them are above upper limit y1, y2, y3 and x4, then we will have to include 5 elbow 20. Therefore final answer is going to be 5 elbow 47 minus 3 times 5 elbow 40 minus 5 elbow 41 plus 3 times 5 elbow 33 plus 3 times 5 elbow 34 minus 5 elbow 26 minus 3 times 5 elbow 27 plus 5 elbow 20. This is little involved because you have 2 different conditions on different variables, but then if we keep doing each and every case meticulously, we will get correct answer. Now let us see the next problem where there are upper limits for every variable x1, x2, x3, x4, x5. All of them to be added to become 50. As far as lower limits of all of them are concerned, they are 0. So we did not have to do the lower limit correction. So we can directly start thinking about final answer. All the cases, if we want to include, it will be 5 elbow 50, because x1 plus x2 plus x3 plus x4 plus x5 is equal to 50. Lower limit is 0. Now because of one of the 5, say for example x1, we want to exclude, then we have to subtract 11 from 50. So it can be done in 5 elbow 39 ways. And for x2 also exactly same. Therefore if we choose 1 out of 5, we have to subtract, we have to exclude 5 elbow 39 in 5 choose 1 ways, that means 5 ways, 1 for each variable x1, x2, x3, x4, x5. Then after excluding these cases, we have to include, because any 2 of them can be greater than 10 and remaining can be less. So in pair we have to include them. So if we consider say for example x1 and x2 are greater than 10, then we will have to subtract 11 into 2, 22 from 50, and that can be done 2 at a time greater than the required ones. We will have to subtract 5 elbow 28, and how many such cases will be there? x1 x2 x1 x3 x1 x4, like that. You choose 2 out of 5, so 5 you choose 2 times 5 elbow 28. So this is exclusion, but then there will be 3 at a time that we are excluding unnecessarily, therefore we need to include them. So this inclusion exclusion will continue. If there are 3, then 5 you choose 3 ways, and total count will be 5 elbow 17, because you are subtracting 33 from 50, and then finally you have to include if 4 of them greater than 10. So 4 of them greater than 10 can be in 5 you choose 4 ways, and if all 4 of them are greater than 10, we have to subtract 44 from 50, and hence their count will be 5 elbow 6. Actually we should, after this we should exclude if all of them are greater than 11, but that case is not correct, because total we have to make 50, and if all of them are greater than 10, it is there is no case like that, it is 0. Therefore we are not excluding again, otherwise we will have to continue. 5 you choose 5 elbow whatever that number is becoming negative minus 5, which doesn't make sense. Therefore the final answer for this question is 5 elbow 50. Include all, then exclude because of 1, 5 you choose 1, because of 1 you exclude, and hence you are excluding cases 5 elbow 39. Then because of 2, unnecessarily exclusions, therefore include 5 you choose 2, 5 elbow 28, then exclude because of 3, 5 choose 3, 5 elbow 17, and then include 5 choose 4, 5 elbow 60. That is what is this problem all about. So if upper limits are same, the calculations become relatively easy. Now the last problem. Let us change the wording of the problem. There is an exam, each subject student can get marks between 0 to 10. In how many ways a student can get 45 marks? This is similar to the earlier problem, but the statement is little different. However, our modeling will be same, x1 plus x2 plus x3 plus x4 plus x5 should be equal to 45, and lower limit is 0, upper limit is 10. Therefore we start our calculations, include all, so 5 elbow 45, then exclude because of each subject. 5 you choose 1, 5 elbow 34, we are supposed to subtract 11 from 45, 5 elbow 34, plus 2 at a time, 5 you choose 2, 5 elbow 23, minus 5 you choose 3, 5 elbow 12, plus 5 you choose 4, 5 elbow 1, correct. And the last term actually should be there, minus 5 you choose 5, but it will become 5 elbow at minus 10, therefore that is 0, so we are not considering that. So if we convert this answer, this should be the correct answer. In how many ways student can get 45 marks, this is going to be the correct answer by inclusion exclusion principle. But let us cross check whether whatever calculations we have learned, we have been doing, are they correct or not. So we just try to find out what is the numerical answer of this. So we convert all elbow notations into choose notations and do the calculations as shown, and we get the final answer as 126. 126 ways students can get 45 marks in 5 subject exams. If each subject they can get 0 to 10 marks. Now whether this answer is correct or not, we can cross check by altogether a different method. If we consider the problem statement as there is an exam of 5 subjects, in each subject student can get marks between 0 to 10, so this part is same. Now we are changing the question, in how many ways a student can lose 5 marks. losing 5 marks is equivalent to getting 45 marks in 5 subject exam, each maximum 10. So which is exactly same meaning. Therefore it is very easy to solve if we consider this problem as losing 5 marks. So our equivalent condition will be x1 plus x2 plus x3 plus x4 plus x5 is equal to 5, where all of them are between 0 to 10. Now even if they have upper limit which is 10, it is as good as they don't have any upper limit, because they can go up to 10, but then numbers after 6 are not going to satisfy this. So we can always consider that it has got no upper limit, and therefore the answer is very easy, which is 5 elbow 5. If we convert it into choose notation, we end up getting 126. So this way or that way we are getting exactly same answer. Not only the answer is correct, but it is confirming to that whatever theory that we are learning, whatever method that we are using for dealing with elbow notation is correct, and it gives you absolutely correct answer. Hope this video will make your elbow notation concept very clear. You will be able to solve many more problems using this concept without any errors. Thank you for watching.